Hello, in this lecture we will find out the radius of the circle. In the drawing we have a circle. Inside this circle we have chord AC that is equal to square root of 2 units, chord PD, chord BB that is equal to 2 units, and this angle DB equals to 45 degrees. Our mission is to find out the radius of this circle. So we'll use two rules in order to solve the question. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. I'll repeat again. The central angle is twice as big as the peripheral angle resting on the same chord. So here we have peripheral angle ACD. This angle is equal to alpha, and it rests on chord AB. We have also this central angle AOB that rests on the same chord AB. Therefore, it will be twice as big as the peripheral angle. The peripheral angle equals to alpha, therefore the central angle that rests on the same chord will be equal to 2 alpha. Okay, so the central angle is twice as big as the peripheral angle resting on the same chord. In addition, we use the law of cosines in order to solve the question. According to the law of cosines, first of all, the law of cosines is true in any triangle, so this triangle ABC could be any triangle. You know that the length of side AB equals to A units, side AC equals to B units in its length, and side BC equals to C units in its length. Then, according to the law of cosines, in this triangle ABC, C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. And from this equation, it is very easy to arrive to this equation that states that cosine theta equals to A square plus B square minus C square over 2 times AB. Again, cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay, so first of all, we define the center of this circle. This point is O. And then we will join together points O and B, points O and D, points O and A, and points O and C by a straight line. Those 4 line segments OB, OD, OA, and OC, they are all the radii, they are all the radii of this circle. Why? Because they start from point O, that is the center of the circle, and ends at points B, D, A, and C. All those 4 points are located on the circle itself. And this is exactly the definition of a radius. Okay, so we define the radius of this circle is capital R, so OB equals to capital R, OD equals to capital R, OA equals to capital R, and finally OC also equals to capital R. In the next step, we will define peripheral angle ADC. This peripheral angle is y over 2 . That is to say, peripheral angle ADC that rests on chord AC equals to y over 2 degrees in its size, and therefore the central angle AOC that rests on the same chord AC must be equal to y. Okay. Likewise, we will define the peripheral angle BAD. This peripheral angle that rests on chord DB is x over 2. So this peripheral angle equals to x over 2, and it rests on DB. Therefore, the central angle that rests on the same chord DB, the central angle DOB, must be equal to x. In the next step, we will focus on the straight line AB, this straight line at point E. We have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of the angles on the upper side of the straight line AB must be equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point E? We have 45 degrees plus the missing angle. In total they must be equal to 180 degrees. So the missing angle must be equal to 135 degrees, or equals 135 degrees plus 45 degrees equals to 180 degrees, exactly according to rule number 1. Okay, and in the next step, we focus on the green triangle AED. On the green triangle AED, we know that the sum of the angles must be equal to 180 degrees. So which angles we have inside triangle AED, the green triangle? We have x over 2 plus y over 2 plus 135 degrees. In total, they must be equal to 180 degrees. I'll repeat again. In the green triangle AD, the sum of the angles must be equal to 180 degrees. Okay, x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. Okay. So we subtract 135 degrees from this equation, and we get that x over 2 plus y over 2 equals to 180 degrees minus 135 degrees is 45 degrees. Here we multiply this equation by 2 and we get that x over 2 times 2 is x, y over 2 times 2 is y, so we have in this side of the equation x plus y that is equal to 45 degrees times 2 is 90 degrees. Okay, we found out that x plus y equals to 90 degrees. We subtract x from this equation and we get that y equals to 90 degrees minus x. Okay. In the next step, we will implement the law of cosines on the pink triangle, ODB. The pink triangle, ODB. According to the law of cosines, the pink triangle, ODB, cosine x equals to r squared plus r squared minus 2 squared, that is 4, over 2 times r times r. So actually, this equation number 1 is the implementation of the law of cosines on the pink triangle, ODB. Okay, so here we have cosine theta cosine x equals to r squared plus r squared is 2r squared minus 4 over 2 times r is 2r squared. So cosine x equals to, here we'll split this expression into 2 parts. The first part will be 2r squared over 2r squared, and the second part will be minus 4 over 2r squared. So we found out that cosine x equals to 2r squared over 2r squared is 1, minus, here we have minus 4 over 2 is minus 2, so we have minus 2 in the numerator. In the denominator we left only with r squared. So actually, according to equation number 1, we found out that cosine x equals to 1 minus 2 over r squared In the next step, we will implement the law of cosines on the yellow triangle, triangle AOC. According to the law of cosines, in the yellow triangle, triangle AOC, we get that cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2, so it is minus 2 over 2 times r times r. Repeat again, in the other triangle AOC, according to the law of cosines, we get that cosine y equals to r squared plus r squared minus 2 over 2 times r times r. Okay, so actually found out that according to equation number 2, cosine x equals to r squared plus r squared is 2r squared minus 2 over 2 times r is 2r squared. So again, cosine x equals to 2r squared minus 2 over 2r squared. Here we'll split this expression into two parts. Two r squared is 1. The first part is 2r squared over 2r squared. The second part is minus 2 over 2r squared. So we found out that cosine x, according to equation number 2, equals to 2r squared over 2r squared is 1. Here we have minus 2 over minus 2 is minus 1. So we have minus 1 in the numerator, in the denominator we left only with r squared. So actually found out that according to equation number 2, here, according to the law of cosines in the yellow triangle, cosine y equals to r squared plus r squared minus square root of 2 squared over 2 times r times r. So this angle is angle y, so it is not x but y. So here we have cosine y. This is cosine y. Also cosine y. So in conclusion, we found out that cosine y equals to 1 minus 1 over r squared. We have already found out that y equals to 90 degrees minus x. Therefore, we substitute cosine y in this equation number 2, by 90 degrees minus x, and we get that according to equation number 2, cosine y is cosine 90 degrees minus x, because y equals to 90 degrees minus x, and cosine 90 degrees minus x is sinus x. In conclusion, we found out that cosine y equals to sinus x. Cosine y equals to sinus x. Therefore, we substitute cosine y in equation number 2 by sinus x. We do it now and we get that here cosine y is sinus x. That is equal to 1 minus 1 over r squared. This is according to equation number 2. While according to equation number 1, we already found out that cosine x equals to 1 minus 2 over r squared. So here we have two equations. We have the expression for sinus x and the expression for cosine x. In the next step, so here we have cosine x equals to 1 minus 2 times r squared. We multiply this expression by 1. Okay. And we will define 1 over r squared as t, and then we substitute 1 over r squared in both equations by t. So according to equation number 1, we get that cosine x equals to 1 minus 2 times 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared by t. So in conclusion, we found out that according to equation number 1, cosine x equals to 1 minus 2t, while according to equation number 2, sinus x equals to 1 minus 1 over r squared. 1 over r squared is t, so we substitute 1 over r squared by t, and we get that sinus x equals to 1 minus t. And according to equation number 1, we found out that cosine x equals to 1 minus 2t. We'll use the trigonometric identity that states that sinus square x plus cosine square x equals to 1. Sinus square x plus cosine square x equals to 1. And we implement this trigonometric identity here in these two equations. So, according to equation number 2, sinus x equals to 1 minus t, therefore sinus square x equals to 1 minus t squared plus cosine square x. Cosine x equals to 1 minus 2t, therefore cosine square x will be equal to 1 minus 2t square. And it is equal to 1 according to our trigonometric identity. So actually we found out that according to equation number 3, 1 minus t square plus 1 minus 2t square equals to 1. We will open the brackets on this side of equation number 3, and we will get that 1 minus t square equals to 1 squared, that is 1, plus t square minus 2t plus 1 minus 2t square equals to 1 squared, that is 1, plus 2t squared, that is 4t square, minus 2 times t, minus 2 times t, minus 2 times 2t, equals to minus 4t, and it is equal to 1. So here t square plus 4t square is 5t square, and minus 2t minus 4t is minus 6t, and here we have 1 on both sides of the equation, so 1 will get cancelled, and we left only this one, so it is plus 1, that is equal to 0. In the next step we substitute minus 6t by minus 5t minus 1t, and we get that 5t square minus 6t is minus 5t minus 1t, plus 1 equals to 0. In the next step, we take 5t out as a common factor from those two expressions in the green color. So 5t was taken out as a common factor of those two expressions. So what is left from 5t squared after we took from it 5t as a common factor? What is left is actually t. And what is left from minus 5t after we took from it 5t is a common factor. What is left is actually minus 1. In the next step, we take a common factor of minus 1 from those two expressions. Minus 1 is a common factor. So what is left from minus t after we took from it minus 1 is a common factor? What is left is actually t. And what is left from 1 after we took from it minus 1 as a common factor? What is left it is actually minus 1. Because minus times minus is plus. And it is equal to 0. In the next step, we take t minus 1 as a common factor from those two expressions. So what is left from 5t times t minus 1 after we took from it t minus 1 as a common factor? What is left is actually 5t. And what is left from minus t minus 1 after we took from it t minus 1 as a common factor? What is left it is actually minus 1. It is equal to 0. So here we will have two solutions to this equation. Equation number 3, either t minus 1 equals to 0, and the second solution is 5t minus 1 equals to 0. We focus on the first solution. T minus 1 equals to 0, it means that t equals to 1. We have, according to our definition, t equals to 1 over r squared. So we substitute t in this equation by 1 over r squared, and we get that 1 over r squared equals to 1. We multiply this equation by r squared, and we get that r squared equals to 1. Here we take a root out of this equation, and we get that r equals to plus minus the square root of 1. The negative square root of 1 is minus 1. But because of the fact that r is a length, and a length must be a positive number, it cannot be equal to, r cannot be equal to minus 1. So we cancel this solution, and we left only with the second solution, that r equals to the positive square root of 1, that is 1. So r equals to 1 units. In the next step, we will focus on the second possibility for the solution of this equation number 3. Here 5t minus 1 equals to 0. We will add to this equation 1, and we get that 5t equals to 1. We will divide this equation by 5, and we get that t equals to 1/5. And according to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared, and we get that 1 over r squared equals to 1/5. Here we will cross multiply this equation, and we get that r squared equals to 5. We take out of this equation, and we get that r equals to plus minus the square root of 5. R cannot be equal to the negative square root of 5, because r is a length, and the length must be a positive number, so we cancel the solution, and we left with the other solution, that r equals to the positive square root of 5. So in conclusion, we have here two solutions that are possible for t, either for the radius, either the radius equals to 1 unit, r equals to 1, or r equals to the square root of 5 units. Okay. Here in the drawing, we have chord dB equals to 2 units. And chord dB, it is absolutely not the diameter of this circle. Why? It doesn't pass 4.0, that is the center of this circle. Any diameter of the circle must pass for the center of the circle. And because of the fact that dB doesn't pass for the center of the circle, it is not the diameter of the circle. So And we also know that the diameter of any circle is the longest chord in the circle. Therefore, the diameter 2r is greater than dB, that is not the diameter of the circle. Repeat again. The diameter 2r is greater than dB, that is not the diameter of the circle. It's given us the equation that dB equals to 2, so we will substitute dB by 2 in this inequality, and we get that 2r is greater than dB, that is 2. We divide this equation by 2, and we get that r is greater than 1. So the solution that r equals to 1 is not correct, because r must be greater than 1. So we cancel the solution, and we left with the only solution that is possible, that r equals to the square root of 5 units. Or in terms of numbers, it is equal to 2.236 units. And that is the answer to the question. I repeat again. The radius of this circle r equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. In the next step, I will summarize the lecture. In this lecture, we found the radius of this circle. Line segment dB equals to 2 units, line segment AC equals to the square root of 2 units, and this angle DEB equals to 45 degrees, and as I mentioned, we have to find out the radius of this circle. So actually, in order to find out the radius of this circle, we use two rules. The first rule is that the central angle is twice as big as the peripheral angle that rests on the same chord. I'll repeat again. The central angle is twice as big as the peripheral angle resting on the same chord. We have the peripheral angle ACB that is equal to alpha and rests on chord AB. Therefore, the central angle AOB that rests on the same chord AB must be equal to 2 alpha. Okay, twice as big as the peripheral angle that is alpha. Okay, that is the first rule, and the second rule is that the law of cosines. According to the law of cosines, in any triangle, this triangle ABC could be any triangle. The length of side AB is a unit, side AC equals to 2 units in length, and side BC equals to 3 units in length. Then, according to the law of cosines, and this angle BAC equals to theta. Then, according to the law of cosines, C squared equals to A squared plus B squared, and 2 times A times B times cosine theta. From this equation, it is very easy to arrive to this equation, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Okay, so we define the center of this circle as O. We join points O and B, points O and D, points O and A, and point O and C together by a straight line. In this way, we created 4 line segments: OB, OD, OA, and OC. All those 4 line segments are the radii of this circle. Why? Because they start from the center of the circle and ends at point B, D, A, and C. All those 4 points are located on the circle itself. And this is exactly the definition of a radius. So all those 4 line segments, OB, OD, OA, and OC equals to R. They are the radii of this circle. Okay. The next step, we define the size of this peripheral angle ADC as y over 2. This peripheral angle ADC that is equal to y over 2 has to chord AC. Therefore, the central angle AOB, that AOC, that rests on the same chord called AC, must be equal to y. Okay. In the next step, we define this peripheral angle BAD is x over 2. Peripheral angle BAD that is equal to x over 2 according to our definition rests on chord DB. Therefore, the central angle DOB that rests on the same chord called DB must be equal to x. Okay. Then we focused on the straight line AB at point E. We have this angle that is equal to 45 degrees, and according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, we get that the sum of the angles on the upper side of the straight line AB at point E must be equal to 180 degrees. So which angles we have at the upper side of AB at point E? We have this angle that is equal to 45 degrees, therefore the missing angle must be equal to 135 degrees. Why? Because 135 degrees plus 45 degrees, it is equal to 180, exactly according to rule number 1. Okay, then we focused on the green triangle AD. In the green triangle AD, the sum of the angles must be equal to 180 degrees. That is to say, x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. I repeat again, x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. We subtracted 135 degrees from this equation and found out that 180 degrees minus 135 degrees is 45 degrees. Okay, so x over 2 plus y over 2 equals to 45 degrees. We multiply this equation by 2. 45 times 2 is 90 degrees. X over 2 times 2 is x, y over 2 times 2 is y. So in conclusion, found out that x plus y equals to 90 degrees. Then we subtracted x from this equation, and finally we found out that y equals to 90 degrees minus x. Then we implemented the law of cosines on the pink triangle DOB. According to the law of cosines, again, in the pink triangle DOB, cosine x equals to r squared plus r squared minus 2 squared, that is 4, over 2 times r times r. And again, in the pink triangle DOB, cosine x equals to r squared plus r squared minus 2 squared, that is r, over 2 times r times r. So cosine x equals to r squared plus r squared is 2r squared minus 4 over 2 times r is 2r squared. Here, we splitted this expression into two parts. The first part is 2r squared over 2r squared, and the second part is minus 4 over 2r squared. So we found out that cosine x equals to 2r squared over 2r squared is 1. And minus 4 over 2 is minus 2, so in the numerator we have minus 2. In the denominator we left only r squared. So according to equation number 1, we found out that cosine x equals to 1 minus 2 over r squared. Then we implemented the law of cosines on the yellow triangle, triangle AOC. According to the law of cosines, this triangle, triangle AOC, the yellow triangle, cosine y equals to r square plus r square minus square root of 2 square. Square root of 2 square is 2, so it is minus 2 over 2 times r times r. It again. Cosine y equals to r square plus r square minus 2 over 2 times r times r. So actually we found out that cosine y equals to r square plus r square is 2r square minus 2 over 2r times r is 2r square. Repeat again. Cosine y equals to 2r square minus 2 over 2r square. Then we splitted this expression into two parts. The first part is 2r square over 2r square, and the second part is minus 2 over 2r square equals to cosine x, of course. So, equals to cosine y, equals to cosine y. It's cosine y here. So, 2r square over 2r square is 1, minus 2 over 2 is minus 1. So in the numerator we have minus 1, in the denominator we left only r square. So we found out that cosine x equals to 1 minus 1 over r square. This is according to question cosine y. It is cosine y here. Cosine y equals to 1 minus 1 over r square. We have already found out that y equals to 90 degrees minus x. So we substitute y in this equation, equation number 2, by 90 degrees minus x. So cosine y is cosine 90 degrees minus x because y equals to 90 degrees minus x. Cosine 90 degrees minus x equals to sinus x. So in conclusion, found out that cosine y equals to sinus x. Cosine y equals to sinus x. Therefore, we can substitute cosine y in this equation, equation number 2, by sinus x. We did it, and we got that cosine y is sinus x, and it is equal to 1 minus 1 over r square. While according to equation number 1, we already found out that cosine x equals to 1 minus 2 over r square. We multiplied here this expression by 1. And we define t as r square, t equals to r square according to our definition, and we substituted 1 over r square by t in both equations, number 1 and number 2. So according to equation number 1, cosine x equals to 1 minus 2 times 1 over r square, and 1 over r square equals to t, so therefore we substitute 1 over r square by t. Therefore it is minus 2t. In conclusion, we found out that according to equation number 1, cosine x equals to 1 minus 2t, when according to equation number 2, we have sinus x equals to 1 minus 1 over r square, and 1 over r square is t. So we substitute 1 over r square in this equation by t, and we found out that sinus x equals to 1 minus t. Sinus x equals to 1 minus t. So we have two expressions for sinus x and cosine x. The next step, we implemented the trigonometric identity that states that sinus square x plus cosine square x equals to 1. We already found out that sinus x equals to 1 minus t, therefore sinus square x will be equal to 1 minus t square plus cosine square x. We already found out that cosine x equals to 1 minus 2t, therefore cosine square x will be equal to 1 minus 2t square, and all it must be equal to 1 according to this trigonometric identity. Then we open the brackets on this side of equation number 3 and found out that 1 minus t squared equals to 1 plus t, 1 squared, that is 1, plus t squared minus 2t. Open the brackets of this expression also. 1 minus 2t squared equals to 1 squared plus that 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t equals to 1. So here we have t squared plus 4t squared is 5t squared. Minus 2t minus 4t is minus 60. And here we have 1 on both sides of the equation, so 1 will get cancelled and we left only with this 1. So in conclusion found out that according to equation number 3, 5t squared minus 60 plus 1 equals to 0. Okay, and here we substitute minus 60 by minus 5t minus 1t, and we got that 5t squared equals to minus 60 is minus 5t minus t, plus 1 equals to 0. Then we took a common factor of 5t from those two expressions in green color. So 5t was taken out as a common factor. Therefore, inside the brackets we have t minus 1. The next step we took out minus 1 as a common factor from those two expressions in the yellow color. So inside the brackets we left with t minus 1 equals to 0. In the next step we took t minus 1 as a common factor from those two expressions, out of those two expressions. So t minus 1 was taken out as a common factor, so inside the brackets we left with 5t minus 1 equals to 0. So here we have two solutions that are possible for this equation number 3. Either t minus 1 equals to 0 or 5t minus 1 equals to 0. So if t minus 1 equals to 0, then t equals to 1. And according to our definition, t equals to 1 over r squared. So we substitute t by 1 over r squared here. And we got that t is 1 over r squared, that is equal to 1. Then we multiply this equation by r squared. And found out that r squared equals to 1. We took a root out of this equation. And found out that r equals to plus minus the square root of 1. R cannot be equal to the negative square root of 1, that is minus 1, because r is a length, and the length must be a positive number. So we cancel this solution, and we left only the only solution for this equation, that r equals to plus 1, because the positive square root of 1 is 1. In conclusion, r equals to 1. According to the first possibility, according to the second possibility that 5t minus 1 equals to 0, we added 1 to this equation and found out that 5t equals to 1. We divided this equation by 5, and we got that t equals to 1/5. And here, according to our definition, t equals to 1 over r squared, so we substitute t here by 1 over r squared and found out that t is 1 over r squared, that is equal to 1/5. Because multiplied this equation and found out that r squared equals to 5. We took a root from this equation and found out that r equals to plus minus square root of 5. R cannot be equal to the negative square root of 5. Why? Because r is a length, and the length must be a positive number, so we cancel this solution that is negative, and we left with the only solution that is possible, that r equals to the positive square root of 5. So in conclusion, we have here two solutions for r, either r equals to 1 or r equals to square root of 5. Okay, so then we focused on this our drawing. In our drawing, called dB equals to 2 units. It is very easy to see from the drawing that dB called dB is not passing for point O, that is the center of this circle. Therefore, dB is not the diameter of the circle. Why? Because any diameter of the circle must pass for the point, for the center of the circle. And because of the fact that chord dB doesn't pass for the center of the circle, dB is not the diameter of the circle. And then we also note that the diameter of any circle is the longest chord in the circle. Therefore, the diameter 2r must be greater than dB, that is not the diameter. Repeat again, the diameter 2r must be greater than dB, that is not the diameter. According to what is given as the equation, dB equals to 2. Therefore, we substitute dB in this inequality by 2. And we found out that 2r is greater than dB, that is 2. We divided this equation by 2 and found out finally that r is greater than 1. So if r is greater than 1, then the solution that r equals to 1 is not correct, because r must be greater than 1. So we have the only solution that is possible, that r equals to square root of 5 units, so in terms of numbers it is equal to 2.236 units. Repeat again, the radius of this circle r equals to either square root of 5 units, so in terms of numbers it is equal to 2.236 units. Okay, thank you very much.